So we want to show this fact here. And in order to show it, we're going to remember what the inverse function means. So in order to do this, we need to know that f inverse of x is equal to just x. Okay, and we use this fact to show that the derivative of the inverse has this nice relationship to the derivative of the original function, where it's 1 over the derivative of the original function with the inverse plugged in. So what we do here is we differentiate. We differentiate this function with, we differentiate this function on both sides. So we go d dx, d dx. And it's clear that the derivative of x, or we should know that the derivative of just x is 1. Now, that's on the right-hand side. On the left-hand side, we get a nice relationship if we can see that this is a plugged-in function and that this is an outer function. We can utilize chain rule. We can say that the derivative of the composition of two functions, right? What is it? It's the derivative of the outer function with the inner one plugged in times the derivative of the inner function. And now it just becomes a simple problem of just dividing on both sides, because I want this at the end, right? That's what's the left-hand side right here. So now I can divide by this on both sides. So I can divide by f prime of f inverse of x on both sides. And I get the desired result. I get that f inverse of f of x prime, the derivative of the inverse function, is equal to 1 over f prime of f inverse of x. And you could use this formula in a lot of ways. This is going to come into play in being able to find the derivative of inverse functions that otherwise would be very tricky to find.